All right, so what we're going to do in this video is we're going to go through how to balance chemical equations and then how to write them from their word equation. Okay, so we're going to start off with chemical equations must be balanced due to the law of conservation of matter. So all that's saying is whatever's on the left side of the equation has to also be on the right side of the equation. They have to be equal. And speaking of the left side and the right side, we're going to use the correct terminology here. So the left side of any chemical equation is called the reactants, and the right side we're going to call the products. So equations are balanced by you're only allowed to do one thing, and that is to add a coefficient. So that is a large number that goes in front. So again, we're trying to balance the equation. We want to make sure the left side equals the right side. So our example here is methane. That was one we did early on in the year when we did the Science of Flames lab. We used methane in our laboratory burners. Okay, so the surefire way to balance an equation every single time is to make a little chart where we count the number of atoms that are on each side of the equation. So I'm going to make my little chart right here. I'm going to put R and P. So that stands for reactants and products. And then I just count each side. So the number of carbons on the reactant side is 1. The number of hydrogens is 4. And the number of oxygens is 2. The product side, I have 1 carbon, I have 2 hydrogens, and I have 2 plus 1. I have 3 oxygens. So you can clearly see this is not balanced. My carbons are balanced, but my hydrogens are not. Now, I ordered them this way also because the biggest tip I can give you guys is whenever you balance equations, you always want to leave hydrogen and oxygen to last. And you always want to balance oxygen last. So that will help a lot when you balance equations. All right, so carbons, there's 1, so that's good. Hydrogens, there's 4, there's only 2 here, so I'm going to add a 2 right there. And now I'm going to come over here, and that's going to make 4 hydrogens. But now I've changed my oxygens. Now I have 2 times 2, so I have 4 oxygens in the product side, but I only have 2 in the reactants, so I'm going to come back over here, and I'm going to add a 2, and now I have 4. So anytime I add a coefficient, it gets distributed to everything in that compound. So I have 2 times 2 is 4 hydrogens, and 2 times 1 is 2 oxygens plus another 2. So that's where I get the 4 from. All right, so again, the chart helps when you try and balance equations. So now let's look at a word equation, and let's see if we can write the skeleton equation. It says liquid pentane C5H10. So they are assuming you don't know the formula for pentane. Now, if you're picking up on this, penta, the prefix for 5, that means it has 5 carbons. If it was something like hexane, you would know that it has 6 carbons, or octane has 8 carbons. So that's how you know the name or how many carbons are in that compound. Okay, so that reacts with oxygen gas. Now, you may be thinking, well, that's an O. However, some of you guys are thinking like, well, no, actually oxygen is always written as O2. You're correct. And we'll go back to that in just a second as to how I know when something is diatomic, when it comes in pairs, when it's by itself. So let's get back to the word equation. So it says to produce carbon dioxide and water, so H2O. Okay, so there's my equation. Now I want to balance it. Now, you don't have to make a chart. You can balance this visually, and that's what I'm going to do. I'm going to start with carbon, because I always want to leave hydrogen and oxygen to last. So there's 5 carbons on this side, so I'm going to put a coefficient of 5 right there. Now my carbons are balanced. Now I'm going to go to hydrogen. There's 12 hydrogens on this side, so I'm going to put a 6 right there. And now if I count the oxygens, I have 5 times 2, so I have 10 oxygens here. 6 times 1 gives me 6, so 10 plus 6. So I have a total of 16 on the right. So if I come back over here and I put an 8, 8 times 2, that gives me 16, and now it's balanced. Okay, so that's balancing equations. Now, If you remember this O2 right here, how do I know that it's O2 and not just O? Well, I'm glad you asked that because that's a great question. So the way that you remember it is right here, Brinkelhoff. Okay, that sounds weird. But what this is it's taking the 7 diatomic molecules, and by diatomic we mean when these guys are by themselves, they always come in pairs. Okay, so it's kind of like conjoined twins almost, where you'll never find them by themselves. They are so reactive that they will always react to form a diatomic molecule when they are by themselves. Okay, remember I'm saying only when it's by itself. Notice right here, I didn't write H2O2 because now that oxygen's in a compound. All right, we're only talking about elements that when they are by themselves, they come in pairs. Okay, and again, here's the 7 right here. It's hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, and iodine. Notice the subscript 2, they always come in pairs. Now, if we rearrange these and make a word out of it, it forms this word Brinkelhoff. And it's just a word that sort of sticks in your brain, and it's an easy way to remember those are the 7 diatomic molecules. Okay. Now, if you don't want to remember Brinkelhoff, you can go to your periodic table and you can just remember that there are 7 of them. And then you can come over to the number 7 on the periodic table and notice that they are all connected together on the periodic table. Okay, so there's nitrogen, oxygen, fluorine, chlorine, bromine, and iodine. Also notice something else that happened when we did this, and please don't say it formed an upside down L. Well, I guess you can look at it that way, or you can think it formed a 7. So it starts with the number 7, they're all connected together, and it forms a 7 on the periodic table. All right, so those are the 7 diatomic molecules. Oh, don't forget, the redheaded stepchild on the periodic table, hydrogen, also a part of that 7 diatomic molecules. So you can remember it by remembering the number 7, they're all connected together, or you can remember the word Brinkelhoff. I'll say Brinkelhoff all the time, so that's probably the way that you will end up remembering it. There's all sorts of them too. There's like Cliff H. Braun, Have No Fear of Ice Cold Beer. There's Hunkelbriff. You're going to hear all sorts of derivatives of that, but Brinkelhoff seems to be the most popular, so we're going to go with that one. All right, so here's some examples of just balancing equations just by eyesight. So you don't really need a chart for this. So I'm looking at this and I notice that there's 2 bromines, but there's only 1 here. So I'm going to put a coefficient 2. And now that changed my sodiums. So I'm going to put a coefficient of 2 there. And again, you guys can pause this at any time and just practice some of these. I'm going to keep going through them just for the sake of time. So sodium and chlorine are balanced right now in this one, but my oxygens, I have 3 here and I have 2 there. So I'm going to have to put a 3 and a 2 to balance out the oxygens. And now I have 2 sodiums and 2 chlorines, so I put a 2 right there. All right, iron, 3. 3. I'm going to leave hydrogen and oxygen to last. So hydrogen is next, 2 here and 2 there. I have 4 oxygens, but I only have 1 here, so I'm going to need to put a 4 right there. But now that changes my hydrogens to 4 times 2 is 8. So I need to come back over here and put a 4, and now everything is balanced. All right, flipping it over to the next page. Do not forget Brinkelhoff, okay? It's very, very important. I put it right here at the top. So now we need to take the word equation and write the actual equation. All right, so hydrogen, H, plus oxygen, O, yields water, H2O. Okay, now you're already probably thinking like, hey, something's wrong here, and it is. Hydrogen is by itself. It's part of the Brinkelhoff 7, so it is a diatomic molecule. It comes in pairs. Oxygen is also diatomic, so I need to put a 2 there. I don't want to balance the equation until I am positive I have written the correct formula. Now that I've done that, now I'm going to balance it. 2 oxygens on this side. There's only 1 on that side, so I'm going to put a 2 right here. And then 2 times 2 is 4 hydrogens, so I put a 2 right there, and now it's balanced. Okay, I'm going to show you one more. Iron 3 chloride, so iron plus 3, chlorine minus 1, so FeCl3 produces iron plus chlorine. Okay, so this is FeCl3 because, again, plus 3 minus 1. Now if I go to the product side, iron is by itself. It's not part of Brinkelhoff, so I'm going to leave it alone. Chlorine is part of Brinkelhoff and it's by itself, so it gets a 2. It's diatomic. Now I'm going to balance it. Okay, so we've got a 2 right here, 3 times 2, so that's 6. 2 right here, and now I am balanced.